Imagine for a moment that you wake up tomorrow and discover that the night lasted 25 hours instead of the usual 24. Does that sound like science fiction? Well, cosmic explorers, not only is that possible, it's happening right this very moment. With each passing year, our days get slightly longer, and the one responsible for this silent change is our closest celestial companion, the Moon. As you watch this video, the Moon is moving away from Earth at a rate of approximately 3.8 centimeters per year. To put that into perspective, it's as if it's fleeing from us at the speed our fingernails grow. It might seem insignificant, but this cosmic dance is shaping the future of our planet in ways you might never have imagined. Today, we're embarking on a fascinating journey to discover why our Moon is abandoning us, how this affects our daily lives, and what this lunar escape means for Earth's destiny. Get ready to find out how the tides we see on beaches are connected to the length of our days, and why dinosaurs lived in a world where a day lasted only 23 hours. Welcome to Cosmic Frontiers, Cosmic Explorers. We are a community passionate about the mysteries of the universe, and we're on an incredible journey towards our first 1,000 members. Each one of you is a fundamental piece in this cosmic exploration. Our story begins billions of years ago, when the Moon and Earth were much closer than they are today. Imagine this: when the Moon formed, about 4.5 billion years ago, it was approximately 10 times closer to Earth than it is currently. If we could travel back in time and look at the sky then, we would see a gigantic moon dominating the horizon, appearing 100 times larger than we see it today. But why is the Moon moving away? The answer lies in a complex and beautiful gravitational dance between our planet and its natural satellite. Think of Earth as a very fast-spinning dancer, completing a rotation in 24 hours, while the Moon is its partner dancing around it, but much slower, taking approximately 27 days to complete an orbit. Here's the secret: the tides we see in the oceans aren't just caused by the Moon's gravitational pull on the water. In fact, the tides create a friction effect that acts like a cosmic brake. It's like when you ride a bicycle and hit the brakes. The energy of motion turns into heat and the bicycle slows down. In the case of Earth and the Moon, the tides create a kind of gravitational brake. Earth, spinning faster than the Moon orbits, pulls the ocean waters slightly ahead of the Moon's position. This misaligned water exerts a gravitational force that accelerates the Moon in its orbit. It's as if Earth is constantly giving the Moon a little push, forcing it to move away. To better understand this process, imagine two ice skaters. One is spinning rapidly and holding the hands of the other, who is spinning slower. Because of the friction and the difference in speed, the rapidly spinning skater will gradually decrease their rotation, while the slower one gains speed and tends to move away. This is exactly the dynamic between Earth and the Moon. The French physicist and mathematician Pierre Simon Laplace was one of the first to mathematically understand this relationship in the 18th century. But it was only in the 20th century that we were able to precisely measure this recession. Today, using laser technology and reflectors placed on the lunar surface by the Apollo missions, we can measure the Earth-Moon distance with millimeter precision. Now, you must be wondering, what is the practical impact of this on our lives? The answer will surprise you. As the Moon moves away, its gravitational influence on Earth gradually decreases. This means that the tidal brake we mentioned also diminishes, causing Earth's rotation to slow down more and more gradually. Currently, our days are getting approximately 2 milliseconds longer every 100 years. Seems little. Let's put that into historical perspective. When the first dinosaurs roamed Earth, about 240 million years ago, a day lasted only 22 to 23 hours. Ancient corals, which grow in daily layers, provide us with fascinating fossil evidence of this phenomenon. Imagine what our lives would be like if days were shorter. Our biological clocks, which evolved over millions of years to synchronize with the 24-hour cycle, would have been completely different. Plants, which depend on light and darkness cycles for photosynthesis, would have distinct growth patterns. The entire terrestrial ecosystem would be fundamentally different. But the effects of the receding Moon go far beyond the length of days. The tides are also gradually changing. With the Moon farther away, its gravitational force decreases, resulting in less intense tides. For life forms that depend on tidal cycles, such as certain mollusks, crustaceans, and algae, this represents a significant evolutionary change over geological timescales. Here's a fact that might shock you. The Moon not only influences oceanic tides, but also Earth tides. Yes, Earth's solid crust also deforms slightly due to lunar attraction, rising and falling a few centimeters each day. As the moon moves away, this effect also diminishes, subtly impacting our planet's geological activity. Let's take a trip to the future to understand the long-term consequences. Scientists calculate that, if nothing else interferes with this process, in a few billion years, Earth and the Moon will enter a configuration called tidal locking. At that point, both celestial bodies will always show the same face to each other, exactly as the Moon already does with us today. In this future configuration, a day on Earth would last approximately 47 of our current days. Imagine, almost 7 weeks of continuous sunlight, followed by almost 7 weeks of total darkness. Temperatures would vary drastically between the day and night sides, creating extreme conditions that would make life as we know it today practically impossible. Fortunately for us, this future is so distant that other cosmic forces will likely interfere long before it happens. In about 5 billion years, our Sun will enter its red giant phase, expanding dramatically and possibly engulfing both Earth and the Moon. The gravitational dance we are observing today will be just a footnote in the cosmic history of the solar system. But there's another fascinating aspect of this story that we rarely consider: the Moon's role in stabilizing Earth's climate. The Moon's presence helps keep Earth's axial tilt relatively stable over millions of years. This stability is crucial for the global climate and for maintaining the seasons as we know them. Planets without large moons, like Mars, can experience dramatic changes in their axial tilt over geological time, resulting in extreme climatic variations. As our Moon moves away and its stabilizing influence diminishes, Earth may eventually experience more pronounced fluctuations in its axial tilt, leading to more severe ice ages or periods of extreme warming. Think about it. The Moon isn't just a beautiful nocturnal companion illuminating our skies. It's a fundamental force that shaped the evolution of life on Earth, stabilized our climate, and continues to influence everything from the tides to the length of our days. Its slow escape is, literally, a change in the very nature of time on our planet. For those of you who like impressive numbers, here's a fascinating calculation. If we could somehow accelerate the Moon's recession to the speed of a car in the city, say 60 kilometers per hour, it would reach the Lord in approximately 260 years. Of course, this is purely speculative, but it helps visualize the vast cosmic distances involved. The discovery and understanding of this phenomenon represent one of the greatest achievements of modern astronomy. Scientists like Harold Jeffreys, in the early 20th century, pioneered the calculation of tidal effects, while the Apollo missions provided the precise tools for direct measurements. Today, a global network of observatories uses lasers to continuously monitor the lunar position with extraordinary precision. It's important to note that, according to our current understanding of physics, this process of lunar recession is irreversible under current conditions. There is no known mechanism that can reverse this trend and bring the Moon back closer to Earth. It is a unidirectional process that will continue until the Earth-Moon system reaches its final state of gravitational equilibrium. Cosmic explorers, we have reached the end of our journey through this extraordinary cosmic phenomenon, but the story we have discovered is truly impressive. First, we learned that the Moon is moving away from Earth at 3.8 centimeters per year due to tidal friction, a process that is making our days progressively longer. Second, we discovered that this recession is fundamentally changing oceanic and Earth tides, impacting all life on our planet. Third, we glimpsed the distant future where Earth and the Moon will be tidally locked, creating days almost 7 weeks long. This discovery reminds us of something profound about our cosmic existence. Even phenomena that seem eternal and immutable, like the Moon's presence in the night sky, are in constant transformation. We live in a dynamic universe, where even the most basic measure of time, the day, is slowly changing over geological ages. When you look at the Moon tonight, remember that you are witnessing one of the slowest and most majestic processes in the cosmos in action. Every moonrise and moonset marks a small step in its eternal journey away from us. A gravitational dance that began billions of years ago and will continue for billions of years into the future. This story puts our smallness and our greatness into perspective simultaneously. We are small in the face of cosmic timescales, but we are great because we are capable of understanding and measuring these fundamental processes of the universe. We are, perhaps, the only known species capable of looking at the sky and understanding not only that the moon is there, but why it moves, how it affects our world, and where it is going. Cosmic explorers, now, I want to hear from you. If you could travel back in time and experience a day on early Earth, when days lasted only 22 hours and the moon appeared gigantic in the sky, what do you think would impress you the most? Leave your reflections in the comments. I love reading your perspectives on these cosmic mysteries. And speaking of mysteries, what astronomical phenomenon do you want me to talk about in the next video? Perhaps the supermassive black holes, the possibility of life on Europa, Jupiter's icy moon, or maybe the enigmatic radio signals coming from deep space. Leave your suggestions in the comments. You are the true navigators of this cosmic journey. We're on an incredible journey towards our first 1000 cosmic explorers. If this video expanded your horizons on how our own planet and its moon are in constant cosmic evolution, join our crew by clicking subscribe. Every new member brings us closer to our goal and strengthens our community of universe-curious minds. Like this video if it changed your perspective on the moon, and share it with someone who is also fascinated by the mysteries happening right above our heads every night. In the next video, we'll explore another cosmic phenomenon that is silently shaping our universe. So turn on notifications so you don't miss out. Until the next cosmic adventure, explorers, keep looking up and wondering about the mysteries of the infinite. The universe is full of stories waiting to be discovered, and we are just beginning our journey through the cosmic frontiers.